Okay, the gas tank in a car holds a total of 16 gallons. The car travels 75 miles on 4 gallons of gas, so 16 in total, and uses 4 of those gallons to go 75 miles. If the gas tank is full at the beginning of a trip, which graph represents the rate of change in the amount of gas in the tank? So as you drive further, you use more gas. The amount of gas you have, which is the y-axis here, is going to decrease, not increase. So this is an increasing slope here, so this one's out. So is this one, it's out. Here it says, they tell us it starts at 16, but here for the first 75 miles, we should lose 4 gallons of gas. So if we look here at about 75 miles, we're at 6 gallons, which means we did use 4 gallons of gas. But here in this graph, we're all the way up at about 12, so we didn't use the amount of gas they told us. So I'll pick choice 1, right? That represents losing 4 gallons in the first 75 miles. Which equation represents a line parallel to the x-axis? Well, just remember, right? I mean, your y-axis is vertical, x-axis is horizontal. So any line on the x-axis has got to be a kind of flat line here with a slope of 0, right? So m has to equal 0 here. But also, it's going to be at some like height. This line, we don't know where the line is, what height. Let's say it was up here at the second dash mark, right? 1, 2. So this would mean y, or the height, is always 2. And that's the kind of equation you would get for a line with a slope of 0. Because if two reasons, I guess, that come to mind for me. For example, the first is y always equals 2. That means the height, no matter where you are on this line, is always 2. So y always equals 2. The second reason you can think about this format relates back to y equals mx plus b. Well, only the b term will be available because m is 0 and that cancels out mx. So you'll get y equals some b term. Mx is canceled out again because the slope is 0, m is 0. So here we'll pick choice 2 where y equals 10. The first choice, x equals 5, is worth noting that if x is 5, 1, 2, 3, 4, 5, you get a line where the slope is undefined. It's a vertical line, but the x value always equals 5. The y value has infinite choices, so x is always 5, so that would be a vertical line or a line parallel to the y-axis. Okay, next question. Here the rate is 120 beats per minute. How many beats would there be if it's 0.75 hours long? So remember, the distance equals rate times time. So we can think of our beats per minute as our rate. So 120 times 0.75 hours, right? What would that distance be, or what would the amount of hours be? We should be careful though, because it's 120 beats per minute. We want to know what will happen if we go for 0.75 an hour. So if that's per minute, let's just figure out really quick how many minutes do we have in 0.75 of an hour. Well, it's 0.75 times 60, which is 45 minutes, right? So it's 120 beats per minute. They're 45 minutes. Multiply them, and that'll be your total, which is kind of like your distance in distance formula. So we have 120 times 45. That's 5,400, or choice 3. Okay. In a linear equation, the independent variable, that's the x variables, right? And dependent is the y, so x is independent, y is dependent. What do they tell us? The independent variable increases at a constant rate, while the dependent variable decreases at a constant rate. So as x goes up, y goes down. You get a line with a decreasing slope, right? A negative slope. So if x is 1, maybe your y value is up here at 5. So we're at 1, 5. Then as I increase x, let's say 2, maybe y is over here at 3. So we go 2, 3. So these points will form a linear line, it's a constant rate, with a negative slope. Undefined slope would be that x, right? So you get a vertical line, we'll show that here, right? Where x is always equal to 2, but y equals any value. A zero slope would be a flat line, let's say up here at 5. Oops, at y equals 5. So here, y always equals 5, no matter what x is. A positive slope could be as x increases, so does y, right? Or as, if you want to say it in a reverse way, as x is getting less, so is y. That would be a positive correlation. Okay, this next one is hard to read. I'll read it for you. In a game of ice hockey, the hockey puck took 8.8 seconds, so t equals 0.8 seconds. Okay. To travel 89 feet, so distance is 89 feet. Determine the average speed in feet per second. So distance equals a rate times a time. We have the time, we have the distance, you want to find the rate. So if distance equals rate times time, the rate equals distance divided by time will equal rate. So that's what we'll do here. We'll do the distance divided by the time. So we have 89 divided by 0.8 seconds. 111.25 feet per second, right? And that's actually above the number of feet we traveled because it didn't travel a full, right? 111.25. Sorry, it didn't travel a full second. It was 0.8 of a second, so it went less than. It could go if it went for a full second. Sorry, it would go more than 89 feet. It would go 111.25 feet per second. And you would write the units too, feet per second. Hope you can read that. Okay, Tom drove 290 miles, so the distance is 290 miles, to go home and use 23.2 gallons of gas. His sister Ann drove, so I'll write Ann over here, distance for Ann equals 225 miles, and she used 15 gallons of gas. Okay. Whose vehicle had better gas mileage? So, with gas mileage, you want to know how many miles you can go per gallon. It's like a rate. So, it's going to be the miles divided by the gallons in both cases. So let's look at Tom first. 290 miles divided by 23.2 gallons. He went 12.5 miles for every gallon he used. Oops, sorry. Whereas Ann, 225 divided by 15, she used 15 gallons. She went 15 miles per gallon. I'll go back and say that because I am tired. I'll be honest here, I'm pretty tired right now, but I'll say that. Again, in the first case, he went 12.5 miles for each gallon, and she went 15 miles for each gallon. So she had better gas mileage because she can go further on a single gallon of gas. Okay. An online music club has a one-time registration fee of $13.95. So $13.95 plus 49 cents for each song, 0.49 for each song X. And Emma has $50 to join the club. What is the maximum number of songs she could buy? This is kind of an inequality because the total number of membership and cost per song has to be less than or equal to 50. Right, that's how much she can spend. So we're solving for x. Subtract 13.95 from both sides. Okay. This cancels out. And we get 0.49x is less than or equal to 50 minus 13.95, which is 36.05. That means that, right, the X, the amount of songs she can buy after she pays for membership, cannot exceed $36.05. That's the amount of money she has. So to solve for this, we divide both sides by 0.49, or 36.05 divided by 0.49. That's just saying, how many songs can you buy with $36.05 if each song is 49 cents. So set it up. And okay, so 73, so X has to be less than or equal to 73.57 songs, but you can't buy 0.5 of a song usually, so she could buy 73 full songs, right? Choice 1. The chart below compares two runners, Greg and Dave, who has the faster rate. So this distance equals rate times time, so rate equals distance divided by time. So we'll use this here to find the higher number. Okay. So, in Greg's case, distance 11 divided by the time 2. His rate was 5.5 miles per hour, mph. Greg is 16 divided by 3, which is certainly going to be a little bit smaller there. 5 and a third miles per hour. Greg has a higher rate. You can justify that. They ask you to justify by showing your work or explaining how you use the distance formula. What is the speed of a paper airplane that flies 24 meters in 6 seconds? So again, distance equals rate times time. And they want to know speed, that's rate. So rate equals distance over time. Just divide here. Distance divided by time. 24 divided by 6, of course, is 4 meters per second. Right? Choice 4. Okay. It takes Tammy 45 minutes to ride her bike 5 miles. At this rate, how long will it take her to ride 8 miles? Here, I'll use a proportion. 45 for every 5, right? How many minutes for 8? Solve for x. We'll multiply both sides by 8. So I get 8 times 45 divided by 5, right? And I'll just set that up here. 8 times 45, excuse me, 360 divided by 5 is going to be 72. So it's 72 minutes. It would take her longer, right? Keep going. If the speed of sound is 344 meters per second, what is the approximate speed of sound in meters per hour? Okay, so it's 344 meters for every second. So that's the distance. Excuse me. 344 meters is your distance you're traveling per second. So your rate is meters per second. Okay, and that's your rate. Well, so for an hour, you get to think that, well, for each second going 344, so for an hour, right, that has how many seconds in it? Well, how many seconds are in an hour? Well, there's 60 seconds in a minute and 60 minutes in an hour. So it's 3,600 seconds for every hour. And for each second, we're going 344. So I multiply that by 344. Oops, sorry. Right? And that's 1,238,400. And you can think of it as a ratio. If it's 344 meters for 1 second, how many meters x would it be for 3,600 seconds? So that's kind of the ratio we were solving here. Okay, let's try some others here. What is the slope in this graph? Well, rise over run, down 2, and then up 3, 6. So negative 2 over 6 is negative 1/3. Choice 2. Joseph typed 1,200-word essay in 25 minutes. At this rate, how many words can you type in 25 minutes? Nice ratio question. It's 1,200 for 25 minutes, right? How many words for 45 minutes? So I'm going to find out how many times 25 goes into 45 and multiply 1,200 by that number. To find out how many times 25 goes into 45, I do 45 divided by 25. 1.8 times 1,200 is the amount of words he'll be able to type. So x equals 2,160 words. Okay. Okay, what is the slope? So it's a positive slope. Cross them out. They're negative here. And I notice I go up 2 over 4. Slope is rise over 1. Run 2 over 4 is 1/2. Choice 4. The number of calories burned while jogging varies directly the number of minutes spent jogging. Right, the more you jog, the more calories you burn. If George burns 150 calories by jogging for 20 minutes, how many calories does he burn by jogging 30 minutes? So I'll use a ratio, 150 calories for 20 minutes, x calories for 30 minutes, or as a proportion, 150 over 20 equals x over 30. However you like to solve this. I'm going to use my ratio here. 20 goes into 30 1.5 times. So 150 will go into this new calorie amount, also 1.5 times. So I just do 150 times 1.5, which is 225, right? Or choice 4. I typed the wrong number in the calculator. Okay, I'll read this one so you can hear it. Sorry about that. Roberta needs ribbon for craft project. The ribbon is $3.75 per yard. Okay. Find the cost in dollars for 48 inches of the ribbon. Okay, so a yard is 3 feet, right? And every 1 foot has 12 inches. So 3 feet would have 36 inches, which means 1 yard equals 36 inches, right? If we want to find out the cost for 48 inches of ribbon, we just set up a ratio. We know it's $3.75 for every 36 inches. We want to know what's the cost X going to be if you have 48 inches. So we want to find out how many times bigger 48 is than 36. 48 divided by 36 is 1 1/3 times 3.75 is 5. So it should be $5, right, for that larger size ribbon. A cell phone can receive 120 messages per minute. How many messages can their phone receive in 150 seconds? So it's 120 messages per minute, or 60 seconds. X messages in 150. Well, 120 over 60 is 2. So X over 150 is 2. Multiply it both sides of 150, and we get 300. Peter walked 8,900 feet. How far, in terms of a mile, did he walk? Well, it tells you here that, I'll write it on the side, 1 mile, right, is 5,280 feet. But we have 8,900 feet, so X miles is 8,900. So I want to find out how many times further did I walk than a mile, and multiply that by 1 to get the number of miles. So 8,900, how many miles go into that? Divided by 5,280. It's about 1.685. So nearest tenth of a mile, 1.7, round up. Right? Choice 4. A turtle and a rabbit are in a race to see who is first to reach a point 100 feet away. The turtle travels at a constant speed of 20 feet per minute for the entire 100 feet. So for the rabbit, For the turtle, remember that distance equals rate times time. And it's 20 feet per minute, so it's 20 feet per minute as our rate times the time equals 100 feet. So this time should be 5 minutes. The rabbit travels at a constant speed of 40 for the first 50 feet, stops for 3 minutes, and then continues at a speed of 40 feet per minute for the last 50 feet. Okay. Determine which animal won the race and by how much time. So the rabbit has 3 minutes to begin, of a rest as well, plus these 2 other rates we're about to find. So the rabbit first travels at 40 feet per minute for the first 50 feet. So 40 times t equals 50. 50 divided by 40 is 5 divided by 4, which is 1 1/4, right? Or 1.25 minutes for the first leg. Then the 3-minute rest. Then 40 feet per minute for the last 50 feet. So it's 40 feet per minute. 40 times t equals 50. So again, it's 1.25. So 3 plus 1 plus 1 is 5, plus 0.25 plus 0.25, so 1.25. 1.25, that's 5.5 minutes. So the turtle wins by half a minute. Classic case of turtle beating the rabbit. In a baseball game, the ball traveled 350.7 feet, that's our distance, in 4.2 seconds, so that's our time. They're going to ask us, what's the rate, or speed? Distance equals rate times time. So distance divided by time, right, equals rate. So what is 350.7 divided by 4.2? 83.5 feet per second, right? Choice 1. Okay, hope this helped.